In this video, we will be going over all of our extra practice problems with L'Hopital's rule. Okay, with number 1, if we go ahead and do our straight substitution, we will end up with 1 over the natural log of 1, and that's going to give us 1 over 0, which is going to imply that our limit does not exist. Okay, with number 2, since we have a polynomial over a polynomial, let's look at our power struggle, so to speak. We will identify the highest power and that term in the numerator, and the same for the denominator, 4x cubed. And so once we look at that, those powers are equal, and so we're going to get answer choice C. Okay, for number 3, it is important for us to remember that A is indeed a constant value. So if I do our substitution, of course, you're going to get a squared minus a squared over a to the 4th minus a to the 4th, or we're going to get 0 over 0. So that does imply that we need L'Hopital's rule. And so here we have the limit as x approaches a, and in the numerator we're going to have 2x. Now that minus a squared, that is just a constant, so it goes to 0. In the denominator we're going to have 4x cubed minus 0. And now when we apply our limit here, we're going to have 2a over 4a cubed, and we have a lot of stuff here that's going to cancel. So it looks like we have 1 over 2a squared. Okay, for our next problem, it looks like it's trying to set us up for L'Hopital's rule again. Notice that we're told what the derivative of f and g are. And also if f at 0 equals g at 0, which equals 0. So that's telling me that this limit as x approaches 0 of f of x over g of x is going to indeed be 0 over 0. That's what this portion is letting us know. So by L'Hopital's rule, we're going to look at the limit as x approaches 0 of f prime at x over g prime at x. And this is where they've told us here that that is really going to be the limit as x approaches 0 of cosine of x over 1. So that's going to give us 1 over 1, which is 1. Okay, for number 5, we have x times cosecant. I would rewrite this so that I have the limit as x approaches 0, and that's x over sine of x. And that puts me in 0 over 0. So now we can do L'Hopital. And so we're going to have the limit as x approaches 0 of 1 over cosine of x. And that's good because that's going to give us 1 over 1. So we get 1 again. Okay, number 6 again is going to be that power struggle. And if we notice, our highest term and exponent there on top is 3n cubed. And the denominator is n cubed, and so that's balanced, and so here we have answer choice D. Right, number 7, again, substituting in that 0, it looks like that's going to lend us to 0 over 0, and so we need L'Hopital's rule. And so our limit as x approaches 0, on top we're going to have positive sine x because of this negative that was already there, and then on bottom, remember that 2 is on the trig function, so we have chain rule here. We're going to have 4 sine x times the derivative of sine of x, which is cosine of x. So again, we have that. It looks like we're going to be able to cancel our sine x. And so if I go ahead and substitute in here, I'm going to get 1 over 4 times 1, or 4. Okay, so for number 8, it kind of looks like that limit definition of a derivative. That's that awful one that everybody tries their best to avoid. We really could approach it. I would, since h is approaching 0, let's go ahead and plug in, and we're going to get 0 over 0. So I would do L'Hopital's rule. And if we do that, we have the limit as h approaches 0. Derivative of e to the h is e to the h, and derivative of 2h is 2. And now if we substitute in, we're going to get 1/2. Okay, so for number 9, again, we could do L'Hopital's rule if we wanted to. Here, nothing wrong with that at all. It's strange looking, definitely, but we could give it a go, or we could try to figure out what our function was. Let's do L'Hopital's rule just for grins. Let's go ahead and see. And it looks like if we substitute in 0, we are going to get 0 over 0. And so let's try L'Hopital's rule. We have the limit as h approaches 0. And L'Hopital's rule here, we're going to have our chain rule. So multiply that down. That's 64 times 1/2. Goodness. Minus h all to the 7th. Well, all of that other is, those are numbers, so that's going to go to 0, and that's all over 1. Well, that's not too bad. So here we substitute in 0. We're going to have 64 times 1/2 minus 0 raised to the 7th. So 64 times 1 over 2 to the 7th. I'm just going to bring that in. Let's see, 64 is going to be 2 to the 6th, 2 to the 7th. So that's going to be just 1 over 2 to the 1st, or 1/2. Or you can multiply that out. I know not everybody realizes 2 to the 6th is 64, so you can multiply that out and break it down, and you'll get the same answer. All right, number 10. Again, plugging in, we get 0, over 0. So L'Hopital limit as x approaches 0. And we're going to have e to the x plus sine x minus 2. All of that is over 2x minus 2. And we're going to sub in, we're going to have 1 plus 0 minus 2 over negative 2. So that looks like it's going to generate a positive 1/2. Okay, continuing on, doing our substitution, and when you know it, you get 0 over 0. So L'Hopital again, we have our limit as x approaches 0, and we have our product rule. So we have the first times derivative of the second plus second times derivative of the first, and that is all over 1. And if we plug in 0, it looks like we're going to have 0 plus 1 times 1, 1 over 1. So our answer there is C. Okay, again, we can do probably L'Hopital's rule again. If we plug in 0, we are going to get 0 over 0. So let's do our L'Hopital. We have our limit as h approaches 0. And the derivative of each of the stuff is going to be stuff prime. So it looks like we're going to get a negative 1 out of that, times e to the negative 1 minus h. That's going to be minus 0 all over 1. And now plugging in our 0, we have negative 1 times e to the negative 1. And so that looks like that's going to be negative 1 over e. So that's answer choice B. All right, so this is an old problem that comes up. And this is really asking about a horizontal asymptote. Notice x is getting unboundedly large. So this is talking about a power struggle. And if you go back to the rates or the growth rates, that's important for us. This is growth rates. So look at this and see, well, which one of these is going to have a limit equal to 0? So remember our ranking, this was super duper slow compared to this. So you know that's going to go to 0. This one, if you look at the ranks, this one's going faster. This is super fast. This one was slow. So that one's going off to infinity. And wow, this one, it almost looks like you want to say it's going off to infinity, but again, that exponential will always grow faster than any polynomial. So that means this one will also tend towards 0. So that is answer choice E. So again, this is a wonderful problem for us to realize how important knowing the growth rates and knowing how they are going to be affected when we look at these ratios. So important. All right, number 14. That's kind of a strange looking one. We're approaching infinity, so it looks like this one, you'll probably end up shooting off infinity over infinity because as x grows. All right, so let's do L'Hopital. We do have our ratio. And a and b are positive constants, so that's good. So we have our limit as x approaches infinity. The derivative of all this is going to be b over bx plus 1 over 2ax over ax squared plus 3. Let's simplify that up a little bit. So limit as x approaches infinity, we're going to do our keep and then change and flip. So I'm going to flip over, and that's going to be ax squared plus 3 over 2ax. Nothing's going to cancel. Oh, duty. We're going to have to multiply this out. So we're going to have the limit as x approaches infinity of abx squared plus 3b. All of that is over 2abx squared plus 2ax. All right, so even though this looks like trash, this is polynomial over polynomial. And why is that good news? Because you can focus on dominant power and dominant power. So looking at those two, that is a power struggle. And so those are competing at the same rates. So we really just focus on those coefficients there. And it looks like we're going to have AB over, that's going to be your AB over 2AB. And those A's and B's will cancel. So it looks like we get 1/2. So that's going to be answer choice B. Okay, our next problem, this is going to be one of those ugly forms. If we do our straight substitution, that is going to give us infinity times 0. And that's not going to be good. So I can't say L'Hopital's rule at the moment. I'm going to have to do some rearranging. So let's see if we can't rewrite this to be a ratio. And I'm going to go ahead... let's not do that. Let me take that off. We're going to say sine of, I'm going to go ahead and do x to the negative 1 because I have a feeling we're going to have to do a derivative. That's going to be x to the negative 2. And so now we've got a good L'Hopital form here going on. And so if we do L'Hopital's rule, then let's see what we're going to get. We do L'Hopital. Then we're going to have our limit as x approaches infinity. The derivative of sine of an angle is cosine of that angle. I don't know why I put a negative there. Times the derivative of that angle. Okay, and then in the denominator, we're going to have negative 2x to the negative 3. Oh, yay. So... this is starting to get weird. Let's go through and see what we can simplify here. I'm going to get rid of those negatives. And that's going to flip, and that's going to just leave me with an x. Okay, so let's see. Now we can talk about the limit. as x approaches infinity. And then we have, since I'm going to evaluate it, I'm going to go ahead and put that back like it was. And then I had an x, and then that was all over 2. So it looks like here we're going to end up with, that's going to be infinity. That's going to be cosine of 0, and that's all going to be over 2. So, yeah, that's just going to tend toward infinity. Remember, that's going to go to 1, not 0. Now, if it went to 0, we'd have to do L'Hopital's rule again for sure. All right. Okay, so now number 16. It looks like it's going to be a troublesome problem for sure. And I think this is one very similar to our homework problem that we did. If we do our substitution, it looks like we're going to get 0 raised to infinity, which we don't want that to go, or not 0 raised to infinity, 0 raised to 0, goodness. 0 raised to the 0. So we need to go through and do y equals natural log of x, all raised to the x minus 1. We're going to do natural log of both sides, and natural log of x raised to the x minus 1. Natural log of y, we're going to move our exponent down, and so we're going to have the natural log of x. That looks just horrible. All right, and so what are we going to do with this mess? Well, if I go ahead and apply the limit now, we have 0 times. That's not going to be good, because then we're going to have a natural log of 0, which doesn't exist. Okay, so let's do L'Hopital. And, of course, we're going to move this part down to the bottom. So let's just focus on that for a minute. So we have the natural log of x over x minus 1 to the negative 1. And so if we do L'Hopital's rule here, of course we still have our limit as x approaches 1. And our derivative here, well, the derivative of the natural log of x, that's going to be 1 over x over a natural log of x, because that's our stuff. And then all of that is over negative x minus 1 to the negative 2. Gracious, let's see what that gives us. So here, simplifying, we have the limit as x approaches 1 of, dun, 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 dun. We've got 1 over x times natural log of x, and then that is all over negative 1 over x minus 1 squared. Okay, so as we continue, we have the limit as x approaches 1 of 1 over x, natural log x, times this reciprocal, which is going to be x minus 1, negative x minus 1, all squared. Gracious, goodness gracious. All right, so what's going to happen now? If I throw in a 1, we are going to get 0 over 0. So we're going to have to go do this again. However, I'm thinking about our growth rates, but that x times that natural log of x, that's going to be too close to try to do. So let's, of course, move out that negative. So we've got natural log, or limit as x approaches 1 of, here, let's go ahead and do our derivative. So that's going to be 2 times x minus 1 over, and then the derivative here, we've got first times derivative of the second Oh, well, that's nice. Plus second times derivative of the first. Hey, this is going to work out quite nicely now. We do have our negative, and then if we start subbing in, that's going to be 2 times 0 over 1 plus 0. So yay, we're going to get 0, but again, that's not our answer. And notice how they put a 0 there. Remember how we had to go back, and this is going to be e raised to the 0, which is 1, so our answer is C.